Now, as we have done the first step, that is crushing and grinding, followed by concentration of ore, then our next step is oxidation. Right, so our next step for metallurgical operation is that oxidation. Right, so we'll be just taking the second step now, that is the oxidation. And what does this step actually involve? What does this step will do for us, for ore? So what we have done, we have just concentrated our ore, and now what we want that our ore is now just free of impurities. We are at a stage that we'll convert our ore now into the metal oxide. So that is we'll do an oxidation, right? So see, what are the methods which are employed for the oxidation? So first of all, you should know that we have 4 kinds of ores. I have already told you. There is an oxide ore, there is an halide ore, there is a carbonate ore, and there is a sulfide ore, right? So we have common 4 types of ores, that is these 4 ones, right? So for we'll be doing different methods for oxidation depending upon that what kind of ore is that. So first of all, you should know that if you get to oxidize the oxide ore, then what you will do, right? Like for example, if I tell you that we have the concentrated bauxite ore, which is Al2O3. So which method you will employ for oxidation? What I want you to answer it. So just tell me that if you have the oxide ore, as I stated in an example, that is the bauxite ore, the concentrated bauxite ore. So what method you would be employing for oxidation? So just by looking at the formula, it should strike to your mind that in this method we convert ore into metal oxide, and the oxide ore is already present in the oxide form. So that means for this type of ore, that is the oxide ore, the oxidation step is actually missed because it is not required, because the metal is already in the oxide form. So we don't need to do the second step when we get the oxide ores. So that means for oxide ore, we will be skipping this step, as ore is already in the oxide form. But otherwise, there are 2 methods for the oxidation. One method is roasting and the other method is calcination. I repeat, there are 2 methods for the oxidation. First of all, for oxide ore we do nothing, right? But other than for other ores, what we have we employ only 2 methods. One is roasting and the other is calcination. So what is actually roasting and calcination, or you can say what are the similarities or what are the general equations or the general procedures which are done in the roasting and the calcination. So what we do in the roasting, we take ore. Similarly, in the calcination we take ore, and that ore should be concentrated. You know that we have to just make it go through this first step, then only we can do the oxidation, right? So here we have the concentrated ore, whether it is roasting or it is calcination. So what we are doing, we are heating ore. Similarly, in calcination we are heating ore. So again the similarity, we are heating concentrated ore in this, and similarly in the calcination we are heating the concentrated ore. But you know what the difference is, where the difference lies? It is that in the calcination we are heating ore in absence of air. There is no air present in case of calcination when we are heating it. But in case of roasting, we heat in presence of air. And the product again is the same, as you know that we are performing an oxidation because we need the metal oxide. So that means whether it is roasting or calcination, the difference lies only in this case that we are heating in presence of air, and in this case we are heating in absence of air. But the product what we are going to get after the roasting and calcination is absolutely the same, that is the metal oxide. Right. So the difference is just the heating. I think it's very simple to learn that it is just obviously the both methods are employed for the oxidation. That means the ultimate product what we will get will be metal oxide. So we are heating in both the cases, but still it is in the presence of air and it is in the absence of air. One more difference that lies between the roasting and calcination, you must be thinking that for which ores we will be doing roasting and for which ores we will be doing calcination. So it is so simple to learn. See, calcination starts with C, so just make an idea that it is used for carbonate ores, Cc. You can just correlate them, right? So that means calcination is done for which kind of ores? Obviously it is done for the carbonate ores. So like I'll state an example. Suppose I have a calamine ore which is a zinc ore, right. So what I'm doing, I'm just heating it in absence of air. So what I'll get, obviously I'll get this is our metal, that means it was in zinc ore, so obviously we need a zinc oxide. So what it gets converted to, it gets converted to the metal oxide, zinc oxide, and just form the respective gases. So which gas will be formed? So obviously it is a carbonate ore, so obviously it will lead to the formation of the carbon dioxide gas. So this is how you'll do calcination. So just let us see now roasting, some example for roasting as well. Suppose I'm just taking you can say the two different ores of the same metal, right. So here we have a zinc ore, that is again the zinc metal ore, but the ore is calamine ore. Here I am stating an example with zinc blende. It is also a famous ore of zinc, which is actually a sulfide ore, not the carbonate one, of the sulfide ore. So what I am doing, I am heating it in presence of air. So what I get, obviously we'll get a metal oxide. So obviously the metal oxide is going to be ZnO. And what kind of gases do you get to see that if when you will burn this sulfide ore, what gas you will get? Obviously we'll get SO2. So that means it is for SO2. So you should know that roasting is done for sulfide ores and calcination is done for the carbonate ores, and for oxide ore this method is not employed. That means because the metal is already present in the oxide form. So this is, we are just done with this third step as well, oxidation. I think it's clear. So we are just finished 3 steps of metallurgical operation. First was the crushing and grinding. You know that we just crush or grind the ores so that we can get a mixture of ore and the impurities. Second is the concentration. You know that in concentration we are separating the gangue particles. So what methods we have already discussed: hydraulic washing, froth flotation, magnetic separation and chemical separation. You know that. After doing this, what we do oxidation, right? And what are the methods employed for it? Obviously, if it is an oxide ore, the method is not required. That means oxidation step is just skipped. Otherwise, for sulfide ores, it is roasting, and for this thing carbonate ores, it is calcination. Now, the next step, what we'll be taking up will be reduction. So this is actually the third step of the metallurgy. And what is that? It is the reduction. Right. As you all know, what is reduction? We already did in redox reaction that what is reduction? Reduction is actually the addition of hydrogen and removal of the oxygen. So this will be doing now. See. So now the third step what we will be discussing will be reduction. Right. So like earlier we have the powdered ore, then we concentrated ore, and then what we did, we converted the ore into the metal oxide. And now in reduction what we will be doing, we will be just employing certain method so that our metal oxide gets separated from oxygen. This is how what we want in reduction, right? Because so reduction means conversion of metal oxide into metal and oxygen, or you can say it is a method which is employed to separate oxygen from the metal, right? So that we can get the metal and we can just purify it and can use in a ready to use form, right? So this is the third step, that is the reduction. Now again, there are many methods which are just employed for the reduction. So what are those 3 methods? First method is by heating. Second method is by use of reducing agent, and third method is electrolytic reduction. Right. So there are 3 methods for reduction. That means there are 3 methods which are employed to separate oxygen from metal. One is by heating, one is by use of reducing agent, and the third is the electrolytic reduction. Now the question must be just kicking your mind that which method will be employed for which kind of metal oxide, or which method will be employed for which kind of metal oxide. So it is very easy. These methods are actually employed according to the reactivities of the metal. As you are familiar that we have the reactivity series, that is the arrangement of metal according to their decreasing reactivities. You know that Kedarnath ka Mali Alu zara feeke se pkata. You know all that reactivity series. So we will be employing these these methods depending upon that whether that metal comes at the top of the reactivity series, or it comes at the middle, or it falls on the bottom. So accordingly we will be using these three methods, right? And this is very important question, and you get it from maximum time it is present in paper in 3-mark question. So you need to be well versed with this question. So again, just look at the board. So first step is by heating. So obviously if we have certain metal oxide and we can just separate the oxygen from metal by heating, so that means there is not so strong bonding between the metal and oxygen, right? So what kind of metal they can be? Obviously there will be metal which are not so reactive, which falls at the bottom of the reactivity series. So obviously suppose we have mercury, like mercury falls at the bottom, it comes in the category of the bottom elements, that means with the decreasing reactivities or with the lower reactivities. So if we have HgO, we can just separate Hg and O simply by heating. So as you can see, I have just heated, so it just separate mercury and oxygen. So that means heating method is employed for those metals which have low reactivities, or you can say which are just placed at the bottom of that reactivity series table. Second is the use of reducing agent. I think you are familiar with the term reducing agent, as I stated in an example of travelling agent. So what does travelling agent do for you? It just make you travel different places. Similarly, what does reducing agent do for us? It is an agent for reduction. That means it helps in carrying out the reduction, and itself it gets oxidized. So which kind of reducing agent we will be using? See, there are so many reducing agents, so we cannot use all those reducing agent in this metallurgical operation. So which reducing agents are commonly employed? They are carbon and aluminium. So two kinds of reducing agents are mostly employed in this reduction process, that is the carbon or in aluminium. So for which metals they are actually used? They are used for those metals which have moderate reactivities, that means which fall in the middle of the reactivity series. For example, we have, I'll take an example of iron. As you know, iron, zinc, aluminium, they all fall in the middle category. So here we have iron oxide, because we need to have oxide. So what we'll do, it will just combine with aluminium. So what aluminium will act as a reducing agent. What it will do, it will just reduce iron and itself gets oxidized. So here we see that it forms iron and it gets oxidized, Al2O3. So this is actually the second process, that is by which we can use the reducing agent, and we can just reduce the metal oxide. One more thing, because I have stated this example for you because this example is itself very important, that there is a special name which is given to this reaction, that is the thermite reaction. That is the thermite reaction. What does thermite word states? Obviously it is related with thermal. Thermal means heat energy. So obviously this reaction involves the lot of heat energy, and where this heat energy is used, or where this thermite reaction is used, it is used for welding railway tracks. So this is an important question, and you get it for 2 marks, that what is thermite reaction, and also state its use. So what you are going to write in, if you get a question like this, you will write that the thermite reaction is that in which the aluminium act as reducing agent. Just state an example, Fe2O3 plus aluminium forms Fe plus Al2O3, right? And then you will be getting that you have to state a use as well. So just write it is used for welding of railway tracks, because it evolves a lot of energy, and that energy is just used in welding purpose. So this is the thermite reaction, or you can say this is the second method, that is the use of reducing agent, which we can employ for all those metals which fall in the middle category of the reactivity series. Now the third is the electrolytic reduction, right? So electrolytic reduction method is actually employed. It is actually employed for you can say the metals which occur at the top of reactivity series. That means they are very reactive. They cannot be reduced by heating. They cannot be reduced by reducing agent. They are reduced by passing electric current. That means by the process called electrolysis. So it is actually an application of electrolysis as well, right? So we'll just get to see what is the electrolytic reduction. So just look at the board carefully.